So the final thing that we are working on is slope. And slope is basically when you are given some kind of graph or you're given some kind of inclined plane and you need to find what the rise is basically in the run. So let's kind of look into this a little bit. If I was given a graph with a coordinate plane and I need to find the slope, all I would need to do is find the rise and then the run. Okay, so the rise would be, well, how tall is it getting? If it is rising. If it's not rising, it would be how short is it getting, basically. So let's look at this rise. If I was going to build let's say a handicap ramp right here on my deck, then I have it at 4 and at 8. So what is my rise? Well, my rise would be y2, which is the second dot, minus y1, which is the first dot. So my second dot would be 8, and my first dot would be 4. So 8 minus 4 would be 4. So that's my rise. And we'll write that right there. Okay, now my run is how far does it go? So it goes from point 1 to point 2. So my second dot is at 2, my first dot is at 1. So 2 minus the second dot minus the first dot. So 2 minus 1 is 1. So my rise over run is 4 over 1. And I can simplify that fraction into just a plain old 4. Now this might look really familiar to you because this is the same equation we were working on a couple weeks ago, y equals mx plus b. I wish that we worked on this before because this would make it a lot easier for you guys to understand how m works. So m is your slope. M is your rise over your run. Okay? So that's really important. Now let's work on a positive slope first of all. So let's look. We have a point right here and a point right here. Well, this is my first point if I'm reading it from left to right, and this is my second point. So my y, my second y would be at 6. My first y is at 1. So my second y is at 6, my first y is at 1. So I'm going to subtract that and I'll get 5. Now same thing, let's look at our x's. My second x is at 6 and my first x is at 0. So I have 6 minus 0. Okay, if I subtract that, I'm going to get a 6. And then it's always y over x, my rise over my run. So I'm going to have 5 over 6. So m equals 5/6. Now let's try a negative slope. So that basically, if you think of like a hill, if you're going down the hill. If you are thinking positive, you're going up the hill. So down the hill, let's check this out. Now y2, so my second y is -1, and my first y is at 3. Okay, -1 plus -3 equals -4. And then x2, so 1 minus -2, parentheses around that, equals, well, let's check this out, plus a positive would equal 3. Okay, now if I put my y over my x, it would be -4 over 3. And I'm just going to keep that fraction improper. Okay, now the other way to think of this is basically when you're counting, well, how many steps down or how many steps up does my slope take? So this would have -4 steps. And then how many steps forward or backwards does it take? So this one would be 3. So my rise over my run. Okay, now let's look at a 0 slope. So this is basically like a flat ground. Now my first y is at 5 and my second y is at 5. So it's not rising at all and it's not shrinking at all. So it's going to be 5 minus 5. which is going to get me 0. Now that seems really easy, but sometimes it is pretty easy. All right, x2 minus x1. So my first x is at 2. My second x is at 6. So 6 minus 2, and I'm going to get 4. Okay, so my fraction is 0/4. Now, if you kind of remember how fractions work, a fraction is literally just a division problem. So 0 divided by 4, which would be just plain old 0. So this slope is a 0 slope, which means it's just stagnant, it's neutral, it's not going anywhere. And finally, what if we have a slope that has all rise and no run? So let's check this out. My first y is 3, my second y is 8. So 8 minus 3. And no matter what, my x is always at 3. So 3 minus 3. Okay, so the first one's going to equal 8. Sorry, 5. And this one's going to equal 0. Okay. So I'll have 5 divided by 0, but unfortunately we cannot do that. So this is going to be undefined. That's how you would define this slope.